Good morning, everybody. I hope you guys had a good weekend. Enjoyed the warm weather. Good morning, Joey. Every time I see you, Joey, or every time I think about, like, see you being, like, in the chat, you just always have a smile on your face. It's really exciting. I hope you had a good weekend. Does anybody have any questions? Sorry, I'm a little late. Good morning, Matt. Questions on anything? I looked at the Discord a little bit this morning. I looked at your guys' quizzes this morning. Oh, good Lord. The practice exam is not posted yet. Trust me, I am probably more frustrated about that than you guys. It will be posted by this afternoon. If it's not approved by the other instructors by this afternoon, I'm pulling an audible and just throwing it out there for you guys. Yeah. Any other questions? How's your homework going? Loops are hard. Loops are hard. They're just different. Matt, what exam did you get? Where did you get this practice exam from? What does it look like? Was it from last semester, 2 semesters ago? Because if it's from more than 2 semesters ago, it's not gonna match. Okay. Once again, make sure they took the exam remotely, because if it's from over a year and a half ago, then it's not okay. Last semester, that should be pretty good. I don't actually know what the practice exam looked like from last semester, but we're essentially doing a very similar process from last semester. Matt, feel free to share that link or whatever in the Discord so other people can use it as a reference. Like I said, ours is going to be posted later today. I'm not going to go through problems on that today. I came up with a new set of problems. I put together so many problems in the last 2 days. I'm so tired and ready to be done. So I made up some more problems this morning that we'll go over. I will post the practice exam. I will post solutions to that. I will post video solutions to that as well. So you guys can hear the process. So you guys should get lots of material to sift through over the next couple days. Is everything you used during? Yes. So you can use the notes. You can use iBooks. That you bring up a really good point, Joey. So as you guys are studying for the exam, as you guys are looking at examples, it's really about examples and just practice and exposure to how to program. So your notes are going to be useful to a point. Your homeworks are going to be useful to a point. Really what I encourage you guys to do as you're studying is to write down techniques. So you guys don't worry about your grade. Just worry about showing me what you've learned. Your grade will come. Let me worry about your grade. Show me what you've learned. You guys should be very proud of everything you've learned. And I know that's cliche, but really, yeah, anyway. So back to Joey's point. So as you guys are studying, take out a sheet of paper and write down, okay, how do you delete a column? So literally write down, delete a column. How do you modify a column? How do you modify a value? Like language, and then what does it look like in programming? So let's start with something, let's go through examples, and I will explain a little bit more about that. So some announcements first before we go. Week 8 material is on plotting. All of that is posted. I just made videos. It's only like 35 minutes or so. I didn't want to bog you guys down with content to go through for week 8. There are 2 homework problems on plotting. They're mostly straightforward. I mean, plotting is just using functions. So go through that on your own time. I encourage you guys to finish all the MATLAB material before the exam. If not, that's fine. Your homework, technically, I have it due on Friday for homework 8. Technically, I don't think it's due until after the midterm. I'll ask the other instructors. But just get all of it done. Plotting is not on the exam, but once again, it's practice using MATLAB. Okay, so let's go start some problems. So here's my first problem I came up with this morning. Oh, here's my nice background. Oh, shoot. Preferences. Sorry, let me just change my font size because it's tiny. Okay, so here's my first practice problem that I came up with. So that just means you have access to, like, you can Google things. Google MATLAB something. You have access to, I mean, technically you need the internet in order to use MATLAB and use all the help documentation. That's what I mean. You can Google things. Like, you're not limited by your notes and Zybooks. I would encourage you guys to still study and write down stuff. But that's what I meant by open internet, meaning you can Google things. I mean, you obviously can't post for someone to give you the solution. You can't use other people. Like, you can't expect a chat back and forth. But you can Google things that already exist on the internet. Okay, so this first problem. Write a function C equals alternate AB, where A and B are 2 vectors of the same length. The function must return C, which is a vector of all the elements of A, alternating, no branching structure or looping structure required. So what I encourage you guys to do when you get to your exam is find an example. For a lot of the problems, an example might be given for you, but if not, then come up with your own. So here's an example for this problem. So I need to write a function that takes 2 vectors of the same size, so A and B. Let's say A has 5 numbers and B has 5 numbers, and then C is just going to be alternating. So A goes here, 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 and here, and then B goes in the other ones. B, 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 B. Okay, so they alternate. So let me go ahead and start. So whenever you start, you click new script. If it's a function, you type the word function, and then you type whatever your function is. Alternate A, comma, B. And this is how you start a function. Generally, the function is going to be told what it should look like, what is your how many outputs do you have, what's the name of your function, what are your inputs. Whenever you write a function, when you save it, the name of the file needs to be the same as the function. So it needs to be alternate because that's the name of my function. Okay, so now I have a function in here called alternate. I can see the file name. I can see my script file, or my function file. And then I'm going to go ahead and actually do my code. So A is, let's say, 5 values. B is 5 values. I'm going to go ahead and start by finding how many values there are in A. So the length of A, is, I'm going to use the length function. L, B equals length B. When you're dealing with vectors, you really should use the length function. So these are some things to write down on your sheet of paper. To figure out how many elements there are in a vector, use the length function. Like, literally write that. If you had a matrix, you might use the size function, and we'll talk about that in a different problem. So the length function, used when finding the number of elements in a vector. Okay, so I found the length of A and the length of B. Starting there. C is going to be another vector that contains A and B alternating. So it's going to contain both the elements of A and the elements of B. So I'm going to pre-allocate C and say that C is going to be full of zeros. That's one row, and then length of A plus length of B. So C, I'm going to start out with zeros. I know it's going to be one row, and it's going to contain as many elements as there are in A plus the number of elements in B. So let's say A looks like this. So here's my example. I'm just going to type these in. 9, 10, 2, 10, 7. So there's A, B equals this one, 2, 10, 10, 5, and 9. So that means LA is going to be 5, LB is going to be 5, and C starts out looking like this. It's going to be a bunch of zeros. You can look at what's printed out in the command window, or you can look at your workspace. It just depends on how familiar you are with each one. Now I'm going to fill in C. So I'm going to go back to my example, and I'm going to start figuring out, okay, what do I want this to look like? So I know I want this number, this number, this number, this number, and this number to come from A. So I'm going to say C, what do I want to change? I want to change elements 1, 3, 5, 7, and 9. I want to change them to my values in A. So start here. So now C has every other element that's equal to A. Start with something and see if you can change it. Okay, so this was 1, 3, 5, 9. Okay, that's a pretty simple array, and there's 2, like it's 1, 3, 5, 7, 9 is all the odd numbers. I could create this a different way. I could say 1, 2, 9 using my colon operator. This will do the same thing. And then let's say that A wasn't always 5, or let's say the length wasn't always 5. I could do to end, say all the way to the size of C, or I could do all the way to 2 times LA. Okay, somehow I want to make this generic to where it's not just if my length is 5. Somehow I want to make it so that if A grows, let's say A was 10, it would work for 10. Let's say you only did to L of A, which would be to 5. If you executed this code, it would give you an error. This is unable to perform assignment because the left and right sides have different number of elements. So highlight, evaluate selection, highlight, evaluate selection, see what happens on your left side, see what happens on your right side. And you figure out, oh, I don't want it to go to 5. I want it to go all the way to 10. So maybe you type in 10, but once again, I want to make it generic so I can use my end keyword. So over here, identifying what do I want to change. I want to change locations 1, 3, 5, 7, and 9. What do I want to change it to? That's what I want to place the values from A there. So that goes back to our left-hand side, right-hand side. What do I want to change? What do I want to put there? Now my other values. C, now I want to change these ones. Location 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10. What do I want to put there? I want to put my values of B. Same idea. How can I recreate this array to make it more generic? I could say 2 to end. I could say 2 to 10. 2 times the length of B. There's multiple ways to figure things out, but we just want to make it generic. So if I highlight this and execute it, I can see that all of my alternate locations are filled with B. And then I can stop there, but I encourage you guys to test your code. So let's say that A was a little bit bigger. I mean, I could just say that A is ones. 1 row, 10 columns. and B is zeros. 1 row, 10 columns. Now I want to say C equals alternate A, B. So I can see it alternates 1, 0, 1, 0, 1, 0. Something, but only input values less than 10. Sure. A equals 1, 2, 3, 4, 5. B equals 5, 4, 3, 2, 1. It's hard to format short. There we go. I think I'd format rat on. So here we go. So A looks like that, B looks like that, here's C. So 1, 2, 3, 4, 5 is from A. 5, 4, 3, 2, 1 is from B. Oops, sorry, wrong one. Does that help, JR? For functions on your exam, don't worry about comments. Don't worry about comments. Just write your function. Add comments for commentary to the grader. Like if you're uncertain about what you are trying to do, or you're trying to do something, that you're not certain, like it's not behaving the way you expect it to behave, add in some comments saying, it's not working, I know, like this only works for a certain number of elements, I can't figure out how to make it work for lots of elements, so say you only went out to 10 here, then just make a comment, this only works for 5 elements of A and B, you know, just add comments for commentary. Don't necessarily add comments because of it's a function. Format rat does rationals, so it shows fractions. Format short does decimals. If the value is greater than something, then do not include it in C. Okay, so hold on. Tidy, could you make a loop using the Horscat method? What's Horscat? Sure. I mean, this is one way to do it. There are many other ways. This is probably the most efficient way to do it in MATLAB, utilizing array indexing. Unless it tells you how to do something on your exam, or it tells you you have to use this, then use whatever method you want. You could use Horscat if you wanted to add one number at a time. That's completely fine. JR, I meant if the value is greater than something, then do not include it. So yes, JR, you could do that. However, that would be a lot more complicated. That's where it might make more sense to use a loop to do it if you're trying to not include numbers greater than 10. I'm not gonna go over that right now because it adds a lot of complexity because A and B aren't the same size then. So you're gonna have to account for which one has a greater size after you remove the values greater than 10. And that's just a little bit more complicated. Okay, so this is one problem. Let's move on to another one. I have 5 prepared for today, so I want to get through as many as I can. Okay, there's that one. Okay, another one. Write a function B equals divide A, row 1, row 2, where A is a matrix of arbitrary size, so A is any size, so M by N, and row 1 and row 2 are 2 indices in row A. I wrote this problem this morning. It's not the best in terms of language. It was not fully vetted, so if it's not clear, I'm sorry. The function must return a matrix B such that B contains the elements of A where the row 1 values are divided by the row 2 values. So here's an example. Once again, try and come up with an example. A lot of the exam problems will have an example to help clarify things. So if A looks like this, and then row 1 is row 2, so row 2, and here's, sorry, I rearranged that. So here's my first input, would be a 2. My second input would be a 1. Then what it does, this is what B would look like. Come on, scroll up. Where it's row 2 divided by row 1. Or, these are my inputs, row 2 divided by row 1. Yes. Okay. Let's do this. So we open up a new script file. Function, B equals divide a row 1, row 2. I do want to note that in your functions, your inputs only show up on the right-hand side. So here my inputs A and B only showed up on my right-hand side. Inputs C or output C shows up on my left-hand side. So in your functions, you only want to use your input values to do operations, to do things. You're not going to assign them. You're not going to say A equals, row 1 equals, row 2 equals. You might say part of A equals, but you're not going to say all of A equals or all of row 1 equals or all of row 2 equals. And then somewhere you do need to say B equals. I'm going to save my file. Once again, it's a function called divide, so my file should be called divide. First things first, I'm going to say B equals A. Because I know that B is going to contain the values of A with modification. So I'm just going to start out by saying B is equal to A. Because I know B is going to contain A with some modification. Okay, so now I'm going to start to change B. So it says that B is going to contain the elements of A, where the row 1 values, so the row contained in this row, is divided by whatever this row is. So my first row, row 1, B, so it's an array, so if I'm talking about a single row, it's whatever index it is, and then all columns. So let's say, in this example, row 1 was equal to 2, and row 2 was equal to 1. I think I did this example wrong. Oh well. So here I'm talking about row 2, looks like this. So once again, writing down on your sheet of paper. To access an entire row, you say a row number, all columns. Okay, this colon stands for all elements in, etc., in a single row in this example. So this, I'm saying I'm going to change the values in this row. In this example, row 1 equals 2. So I put a 2 here. In reality, though, this is going to be row 1. There we go. There's my commentary. So I'm going to take that row and I'm going to divide it by whatever this row is. So example, row 2 equals 1. So B, I'm going to take row 2, I'm going to divide it by row 1. Once again, in my example, it was 2 and 1. If I wanted to make it generic, I would use my inputs. So maybe start with an example, and then use your variables. This example is not very clear. But let's say A looked like this. Step through what this is happening. 10, 3 rows, 4 columns. Row 1 equals 2. Row 2 equals 1. So first I say B equals A. So B equals my original values of A. And then I'm taking this row, so row 2, and I'm going to divide it by the numbers in row 1. Note when I did that, I got one number. Because I should use element by element notation. If you're ever expecting in a vector, an array, and you don't get one, it's probably because you forgot to put a period somewhere. So just go through, put a period. So now when I do this, I should end up with an array of values where it's 5 divided by 3, 10 divided by 10, 4 divided by 5, and 2 divided by 4. So here it is in decimals. If you ever want fractions, just say format rat, and then just redo the operation. It'll give you the fractions. And if you want to go back, just say format short. Are the percentages still off for the grades under UWeLearns? So they are, as everything that you see there, everything that you see is incorporated into that percentage. Homework 6 is still being graded, so by hopefully tonight, the percentages will be static for a little bit. Tomorrow I'm going to finalize grading your comprehension quizzes. So tomorrow they should be what they are. I'll send out an email. Okay, so if I want to do the whole thing, if I want to say B equals divide A, row 1, row 2, there's my final answer. Where A looked like this, and here's B. Row 1 is the same, row 1 is the same, row 3 is the same, and row 2 was divided by row 1. No, Aurora, you would not lose a point if you have an unnecessary number of periods. You would lose points if it doesn't work, but if it works, then you're fine. You could also do this with loops, but once again, I'm trying to do these first examples, starting with the beginning material, and then Wednesday we'll go over some of the more later material. Okay. Like I said, came up with that. Well, I came up with all these this morning, but that one's probably, I could have done better on that one. Okay, let's go over another one. This one will probably be interesting. Most everybody was like, let's go over, what is it called? Logical indexing. In the problem statement, what does 2 indices of rows? So the row index. So when it says row 1 and row 2, it's the row indices, so the index. So when it says row 1 equals 1, it's talking about all of row 1, or all of row 2 and all of row 1. So it's not saying a single index, it's the row, the entire row. Okay, so here's another one. So it says write a script file categories.m. If you're told to name your script files appropriately, just save it right away. Categories.m. That prompts the user for an array of values. Once again, we've got the keyword prompt. Prompt means input. So prompt the user for an array of values. For your home or for your exam, you might be told what to use for your prompt, you might not. So just come up with something simple. So A equals input. Enter in an array of values. Remember, keep in mind, I'm gonna make this short because I'm running out of space. Keep in mind that you have 2 options for input. If you're expecting numbers, you do this. If you're expecting text, you do this. Okay, so keep in mind to add in this additional option if you're expecting some sort of text. I am not. I'm expecting numbers, so I'm gonna leave it off. Then it says the script file must then determine the types of numbers that are contained in the, array. Once again, I wrote these this morning, they have not been vetted. By determining the values in the array that are positive, negative, even, odd, prime, integer, and non-integer. This one's a little longer than you might see on your exam, but I wanted to go through like all possibilities that you might ever run into. Okay, so I have an array of values. Come up with one. Let's say A equals 1 to 20. It's just a lot of numbers. Come up with an example. A equals 1 to 20. Now I want to figure out which of them are positive, which of them are negative, which of them are even, odd. I should probably have some negative numbers in there. A equals negative 10 to 10. There we go. So this is where we have logical indexing. A greater than 0. Let's say 0 is positive. There you go. That's our logical indexing. Which of the numbers inside of A are greater than 0? You can do this in 2 steps if you want. You could say positive locus equals A greater than or equal to 0. And then do this. Positive numbers. This is fine. Positive locus would look like this. It's going to give you 1s and 0s, a 1 wherever it's positive, a 0 wherever it's not positive. And then pos here would give you all of those positive numbers, which is 0 through 10. It might be clearer if you do it this way. So here's all my positive numbers. Here's my negative numbers. A less than 0. Even numbers. So here's my even numbers. If you ever want to figure out if a number is even, there's a couple ways to do it. One of the ways is by dividing your numbers by 2, rounding that, and see if they're equal to if it's not rounded. So A divided by 2 looks like this. Rounding it. And here's A divided by 2. Notice some of them are whole numbers, some of them are fractions. Wherever they're equal, that's where it's even. So once again, write down on your sheet of paper, how do you figure out if a number is even? This is one of the methods. You can also use this method. A2 equals 0. Mod looks for the remainder. So it literally divides your numbers by 2, and it looks for a remainder. So here the remainder is 0. Here's the remainder of 1. 0, 1, 0, 1. Wherever it's 0, that means it's even. It's evenly divisible by 2. So write down on your sheet of paper, even numbers. Check if mod A, comma 2 equals 0. So when I'm talking about writing notes, I'm talking about what are the techniques you're using. Not so much of what does an if statement look like, but what does it look like to write an if statement? Not what the mod function does, but what does it look like to check if a number is even? Matt, don't be so worried about your grade right now. Okay, so there's even numbers, odd numbers, same thing. We do the same process, but check to see if it's equal to 1. So notice these are the even numbers, these are the odd numbers. Then it says the prime numbers. I would say use loops only if you're told to, or if you can't think of anything else. But I mean, don't sit there and be like, how do I use this how do I not use loops for this problem? Because loops are new. If loops are the first thing that comes to your mind, go ahead, use loops, unless you're told not to use loops. For this problem, we were told, never mind, for this problem, we were not told. But if you are told to use loops, use loops. If not, then you don't have to use them. So I would try to come up with ways to not use them. Prime numbers. So prime, this is one I came up with. There's an is prime function. So I could say is prime A. It only works for positive values, so I could see prime absolute value of A. So if I do this, there we go. There's all my prime numbers. This one's prime, this one, this one, this one, this one, this one, etc. Integer numbers. If a number is an integer, that means it's a whole number. So to figure out if they're an integer, I could say I could round them, and it's equal to my A value. So is the rounded version equal to my original version? And non-integers. Same thing, just opposite. If the rounded version is not equal to my original version. So there's lots of ways you guys can put together these conditionals. This is logical indexing. This is where you're saying grab all the values in A where A is greater than or equal to 0. Grab all the values in A where A is less than 0. Grab all the values in A that are even. Grab all the values in A that are odd. Grab all the values in A that are equal to their rounded value. And grab all the values in A that are not equal to their rounded value. And then last thing for this problem, it says display the results in the following format. So we used input for this, input an array of values. I also want to display my results. So there's a couple ways to do this. You could use fprintf, positive numbers, and then fprintf, %d, space, pause. Remember, this is what you did for that one homework, where this is what it looks like to display your array as a row. And then fprintf \n. You could do that. You could also use disp. So disp, if you're combining text and numbers, you want to use your array. So you want to use your open close brackets. So I'm combining the text negative numbers, and then I'm combining the text num to string neg. So literally the values inside of negative, my negative array. So there's several ways to do this. I'm gonna keep doing it this way because it's shorter. Use whichever one you want. Don't be afraid to copy and paste. And then I need to change these. So negative, even, odd. Like I said, this one's a little long for your exam. I just wanted to be thorough. Okay, so let's run it and see what happens. So run, enter an array of values. I'm gonna make a random array from negative 10 to 10. I'll make it negative 20 to 20. 20, one row, 20 values. I'm gonna divide it by 2. Okay, is prime in line 7. So I got an error, that's fine. Let me just test it. If you ever want to stop your program, just press Control-C. It's true for anything. Note it asked me to re-enter in my values for some unobscure reason. It didn't just exit my program, so I decided to make it exit myself. Okay, so A contains all of those numbers. Is prime absolute value of A? They are non-negative numbers. Oh, non-negative integers. Okay, so I'm gonna cut this one out. They need to be integers, which I changed it, which is fine. If you were asked to figure out if they were prime, they would be integers. Okay, so let's run this again. There we go. So here's my results. Here are all the positive numbers. Here are all the negative numbers. Here are the even numbers, the odd numbers, the integer numbers, and the non-integer numbers. I could fix the prime by just saying round absolute value. Let's do that. Run it again. There we go. There's all my prime numbers. It's a bunch of ones and zeros, apparently. That's why. A. There we go. So I got ones and zeros, which is my logical array. I need the values inside of A. There we go. There's all my prime numbers. Note it includes these because they were rounded. So once again, I could keep massaging that and going through and changing that. But like I said, this is a more thorough example, and I want to move on to others. But this is logical indexing. Grab all the values in A where A is greater than or equal to 0. A is less than 0. Here's what's even. Here's what it looks like to be odd. Here's for prime numbers. Here's for integers. Here's for non-integers. Okay, let's go on to the next one. Ooh, this one's fun. Okay, write a script file, remove invalid data. Okay, write a script file, remove invalid data. I don't know what it does, but I don't care. I know I need a script file that reads in a file of data from data.txt. Okay, which means I need the load function. So load data.txt. This is one way to do it. You also could say load data.txt. Either one will work. Data.txt needs to be in your current folder, which here it is. So start there. If you load it, you can open it up and see what it contains. So this is what this file contains. Note there's a bunch of NaNs in here. NaN is a number. It's not a number in MATLAB, but it's valid. Those are valid numbers. Okay. Then it says your script file must remove all of the rows. So I need to remove rows. So go to your file somewhere on your cheat sheet or that you've written down. Delete rows looks like this. What row? All columns, open brackets. So here's how you delete a row. That contain invalid data or data that is not a number. Save the new data with the invalid values removed in a file named validdata.txt. So first I'm going to go through all of my data and I'm going to remove rows. Okay. You can do this without loops, but you also can do it with loops, which is a little bit more straightforward. So the number of rows I have is equal to the size of data, 1. Okay, so this is one of the ways to use a size function. So this tells me how many rows I have. So once again, write down on your cheat sheet, determine number of rows, looks like this. Oops, wrong one. R equals size A, comma 1. So somewhere you have code and you have what it does written down so that you don't have to sit there and bang your head against the wall and try and remember. Okay, so R equals size data, comma 1. That's how many rows I have. So I'm going to iterate through all of my rows. So for I equals 1 to rows. I don't need that other end. It's not a function. So for I equals 1 to rows. Okay. I am going to print out data over here just so I can see what it looks like. Okay, so for each row, I need to check to see if it contains not a number. So I'm going to say that A, my row, all columns. So for my first one, I'm going to see if it's equal to NaN. This is what it would look like. So let's say that R equals 1. Oops, it's called data, not A. This is equal to NaN. It's not giving me a correct answer. It's not giving me a 1 here, but if I hover over this, MATLAB says use is NaN when comparing values to NaN. So I'm gonna do that. So sometimes MATLAB shows you what you should do. I don't think your exam has NaN, I just used it as an example. Okay, so now it gives me my 1. So I'm just checking to see, does my row contain an invalid value? Is it equal to NaN? Note, it gives me a 1 by 5 logical array because my row contains more than one answer. If I wanted to use an if statement, I need to combine this into one single number. So I'm just gonna sum it all up. Because if there's none, the sum of this should be 0. If there's more than 1, if there is 1, it should be greater than 1. Okay, so my sum here, invalid, is going to be 1. So if invalid is greater than 0, this means that I have a row that contains an invalid number. So I know I want to delete that row. So I want to delete row 1 because it contains an invalid number, not row 2, not row 3, row 4, not row 5, row 6, row 7, etc. So if it's invalid, I'm going to create another array that contains all of my rows I'm going to delete. So delete rows equals 0 right now. So delete rows equals an array of 1. There are other ways to do this, but that's what we're going to do. Somewhere I'm going to keep track of all the rows to delete. I could make delete rows a bunch of zeros and 1 to R. There we go. Ooh. Oh, right. So I'm just going to put a 1 in every row that I need to delete. So if I run this, if I execute this, there we go. Delete rows looks like this, where there's a 1, or there should be a 1, in every row that contains not a number, which there's not. I should have written my answer. Okay, let's go back to what data looks like. Data looks like this. So I'm iterating through all the rows 1 to R. If you ever run into something where you can't figure out what to do in your code, at least quickly, write some comments like this. Who cares if your code doesn't work properly? You're gonna get partial credit. So here's where comments come into play. So here it says, keep track of the rows to delete. Check if a row is invalid. Something to indicate that this is what this code is meant to do. It may not do that properly. So here, go through all the rows. So row 1, 2, 3. I don't know why it's not working. Invalid. If invalid is greater than 0, put a 1 in I. There we go. I need I, not R. Okay, there we go. That's better. So delete rows. I transpose it. So here are all the rows that contain an invalid value. So I've gone through all the rows. I've detected if it contains an invalid value. I encourage you to not delete them inside of a for loop. In general, if you have I going from 1 to R and R is dependent on the size of data, don't modify data, don't modify I, don't modify R until you're done with your loop. So I don't want to delete the rows of data because that's going to mess with my iterations. That's going to mess with my loop. Somewhere I'm going to run into some error. So that's why I have this code that says keep track of the rows to delete separately so that I can delete them. So here's what I do. So there's a couple ways to do this. You could do it this way, where you have your 1s and 0s, and then you could do logical indexing. So you could say which rows you want, delete logical, delete rows, all columns equals that. Once again, it's not called A, it's called data. Spelled correctly. So it deleted all the rows. So this is one way to do it. We could also keep track of which row numbers it is. So we could say that delete rows starts out with a empty array, and then I can keep track of equals delete rows next to I. So here I'm saying combine my original delete rows array and then add a new number. So here is delete rows, it looks like this. So it starts out with 1, then it goes to 1 and 4, and then 1, 4, 6, then 1, 4, 6, 7, then 1, 4, 6, 7, 12, etc. So this is another way to do it. A little more complicated. You might have seen this in your Zybooks. There's other ways to do it as well. If you come up with a different way, that's totally fine. You could do this without loops, but here's one way to do things. So then you would just say delete rows equals empty. Notice you have a loop. If you want to go through all of the elements in a single row or a single vector, go 1 to the number of rows. Or if you want to go through all the elements in an array, you might want to go 1 through numeral R or numeral A. Once again, this one is a little bit more complicated than you'll see on the exam, but I wanted to use it as an illustration because there's a lot here. This literally contains everything we've learned. We've got the size function, we have array indexing, we have deleting values, adding values, we've got functions here, we have load, I can save my results, save, was it valid data.txt, comma, data, and then ASCII. So yeah, so there's a lot here. So let me do this in multiple steps. So invalid here, this first line, is checking to see, it's essentially just saying, does the row contain any not a numbers? So like I said, data I equals NaN. So this is what you might think to use. MATLAB told us to use a different function, so we use that instead. But it's saying, okay, so the row, so row 1, row 2, row 3, row 4, row 5, is it equal to NaN? This is an array, this is a scalar. It contains conditionals, it contains if statements, loops, there's like everything literally that we learned is in this problem. But this is a scale. This is an array. This is a scalar. So it's going to check all of the values with NaN. It's going to give a 1 or a 0 for every location. So if there's a 1, if there is not a number, yes. So is NaN it's a MATLAB function. It's a built-in MATLAB function, like the sum function or the size function or the log function or the exp function. And then I'm just summing those up. Because if it does detect at least 1 NaN, if there's 0 NaNs, then the sum is going to be 0. If there's 1, there's going to be 1. If there's 2, it's going to be 2. If there's 3, it's going to be 3, etc. So I have to, when you use an if statement, it has to be with a scalar. I couldn't say if invalid. I couldn't just say if invalid equals, or if, I couldn't just say this. Because your if statement doesn't know what to do in this situation. So you have to convert this to a scalar, which I did that with sum. So if invalid is greater than 0, then I'm going to keep track of which rows I want to delete. This here is also complicated. This is how you essentially add elements each time you go through a loop. So delete rows, here it's just an empty array. So the first time through, delete rows is empty. So I'm adding empty plus whatever my row is. The second time, it contains whatever that previous row was. So I keep those elements and add a new element. And then I keep adding new elements to my array. So first it's empty, then I add 1 number, then 2 numbers, or then another number, then another number, then another number, and then another number. So there's a lot here. So if you understand what is happening here, then you understand quite a bit. Okay, the last example I prepped for today was this one, where it just says write a script file that solves the following system of equations. So this is where we have ax equals b. We put together a. Where a, I have three unknowns, x, y, z. So for my first equation, it would be 1, 2, 0. My second equation would be 0, 1, negative 1. My third equation would be negative 2, negative 1, negative 3. B is my vector of my right hand side, so negative 11, negative 1, and 19. So in my program, I would literally just type A equals 1, 2, 0, 0, 1, negative 1, negative 2, negative 1, negative 3. Type B equals negative 11, negative 1, 19. And X equals A, left divide B. That's it. Name it system.m. I know we're out of time. So there we go. I feel like I typed it in number incorrectly. A should not be singular. So when it says close to singular, it shouldn't look like this. I must have written a number down incorrectly from this morning. I'll just change it. There we go. That's better. So let's say A looks like this. B and X, literally this is all your program needs to be. You do not need to start out A with zeros. Just type it in row by row. You can also type it in like this. Sometimes it's a little clearer. You can keep track of all of your numbers correctly. If you want to type it nice and square. If you are asked to display your results, you can do fprintf, x equals percent, I don't know, 0.2f, x. That will print out your results like this. It'll repeat this whole text for every single value in x. So, Joey, we don't use the dot here because we're not trying to do element by element. We are trying to do matrix math in this instance. We are trying to do x equals A inverse B, which in MATLAB is A left divide B. Or you could do inverse of A times B, or A raised to negative 1 times B. There's lots of options. But literally, if you're asked to solve these system equations, just type out X, type out B, or type out A, type out B. This is always that same line. And then if you want to print out your results, if you're asked to display your results in a specific format, use that format. But this is what it looks like to print out all of your X values. Technically, it should be X, Y, Z, but sure, I'll do X, Y, Z. X, Y, Z, where my X is the first number, my Y is the second number, and then the third number. There we go. There's my answers. Okay, we are out of time. I have to run over to office hours. I will have more problems for you guys on Wednesday to go over. Hopefully they're a little bit more vetted than this morning's that I put together. The practice exam will be posted by this afternoon. Make sure you guys go through it. I will have solutions and video solutions for those as well. Don't forget to plot things. And it's going to be great. It's going to be great. I'll see you guys on Wednesday.